For the last 20 years of his life, Albert Einstein sat in front of chalkboards just like this, trying to kill a theory he hated. He was fighting a concept so strange, he famously called it spooky action at a distance. Tell me in the comments, do you think any force could ever travel faster than light? To see why Einstein was so bothered, look at classical physics through a pair of gloves. If you pack a left-handed and right-handed glove into two separate boxes, then send one to New York and the other to Tokyo, the moment you open the New York box and see a left glove, you know the Tokyo box holds the right glove. There is no communication between the cities. The gloves had a set shape from the moment they were packed. In classical physics, particles act the same way, carrying internal code that dictates their definitive state. This intuitive view is called local realism. It assumes objects possess definite properties, even when no one looks at them. But quantum mechanics proposed a far stranger reality. It claimed particles have no definitive state at all until the exact moment they are measured. When two particles entangle, they enter a locked relationship. Measuring one undefined particle instantly forces its distant partner to snap into a matching state. This connection happens regardless of the distance between them. It bypasses the speed of light, acting as if space and time do not exist. In 1935, Einstein's team published the EPR paper, accusing quantum mechanics of being incomplete. They argued for hidden variables, hidden inside the particles, just like the boxed gloves. The ultimate stakes were clear. Einstein's defeat means reality remains undecided until observed, destroying centuries of human intuition about local space. For decades, this remained an unsolvable philosophical debate. Then, in 1964, a physicist named John Stuart Bell realized the argument could actually be resolved mathematically. Bell designed a mathematical lie detector test, known as Bell's Inequality. He built it to explicitly check for those classical hidden variables. If you want to dive deeper into the intense rivalries of these quantum physicists, check out the Audible link in the description to hear their stories in full. This graph illustrates Bell's logic. He calculated that if Einstein was right, if classical hidden variables dictate particle behavior, the correlation between particle measurements is capped at a strict mathematical limit. Bell's equation created a definitive trap. If a physical experiment could ever break past that mathematical ceiling, the classical worldview would be proven impossible. By the 1970s, experimental physicists like John Clauser and Stuart Friedman built the physical machinery required to execute Bell's test on real particles. Look at the resulting data. The measurements from the entangled particles consistently and spectacularly spike above that classical limit line. The courtroom verdict was in. The universe does not use hidden variables. Einstein's 1935 accusation was wrong. This data proves that particles genuinely have no definite properties until the exact moment they are observed. The local realism worldview is over. The universe operates non-locally, meaning observation shapes reality across vast distances. These experimental results received the ultimate scientific validation via the 2022 Nobel Prize in Physics. Physicists Elaine Aspect, John Clauser, and Anton Zeilinger closed the remaining loopholes, proving that the universe is interconnected at a subatomic level. If your understanding of reality has shifted even a little bit today, take a second to hit the like button. Laboratories have moved from confirming these effects to utilizing them as a form of precision engineering. Solving Einstein's puzzle transformed a theoretical anomaly into the foundational architecture for a new class of computation. This schematic shows the mechanics of quantum teleportation. By utilizing an entangled pair, the exact state of a qubit, labeled C, is transferred instantly to a new location without moving any physical matter. This exact same principle now enables highly secure, unhackable communication networks to be beamed down directly from orbiting satellites. Meanwhile, quantum computers use these entangled states to process information exponentially faster than current supercomputers. The universe is not a series of isolated cogs. It's an interconnected system where distance doesn't prevent influence. Make sure to subscribe, because tomorrow we are breaking down exactly how quantum teleportation protocols work in the real world. See you then.